All right, we're going to talk about deductive reasoning. So, deductive reasoning, sometimes called logical reasoning, is the process of reasoning logically from given statements or facts to a conclusion. Okay? So, deductive reasoning. You guys have done this. You solve a math problem, 2x plus 3 equals 5. That's deductive reasoning. Okay? Law of detachment. If the hypothesis of a true conditional is true, then the conclusion is true. So the law of detachment is if this is true, then the conclusion is true. Okay? Using the law of detachment. Okay, so here's what it says. If a student gets an A on a final exam, then the student will pass the course. Okay, so that's our if-then statement. So if a student gets an A on the final exam, then the student will pass the course. Now what we're looking at, we're using this law of detachment. We're going to talk about a very specific case. Felicia got an A on her history final exam. Okay, so since she got an A on her history exam, what is the conclusion? Well, the conclusion is she will pass the course. Okay? So that's my law of detachment. She will pass her course. So here's our next one. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Okay? So here's my conditional. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Ray, RS, divides angle ARB so that angle ARS is congruent to SRB. Well, what does that tell us then? Well, it says then the ray is an angle. So I would say RS, ray RS is an angle bisector. Okay? So we're going to take our conditional statement. So the law of detachment says take your conditional statement. We're saying that this is a true conditional. Then we get a very specific part on it for that talks about the first part of it. Okay? That talks about the hypothesis. If we know the hypothesis is true, then we know the conclusion is true. Okay? Our next one says if two angles are adjacent, then they share a common vertex. Okay? So, remember here that if two angles are adjacent, this part has to be true. If two angles are adjacent, then they share a common vertex. Okay? Angle 1 and 2 share a common vertex. That's nice, but what is common vertex in our if-then statement? It's our conclusion. So because it's our conclusion, we don't have any knowledge about angle 1 and 2. Okay? So there's nothing we can write from this. Okay? Remember that it has to be the first part of the statement first. If we have that, then we can say the second. But since this is the conclusion of our statement, we don't know anything about 1 and 2. Okay? So there's no conclusion we can draw from that. Law of syllogism. Okay? So the law of syllogism allows you to state a conclusion from two conditional statements when the conclusion of one statement is the hypothesis of the other. Okay? So this may sound a little strange. So it says, if P then Q is true and Q then R is true, then P then R is true. So if you remember the transitive property, kind of think of it like that. A equals B, B equals C, so therefore A equals C, right? So what we're doing is we're going to take out, so if I were to look at this as just statements here, P then Q, Q then R. So notice that these have to be the same. If those are the same, I'm going to get rid of it and say P then R, okay? So that's that law of syllogism. Now this is sometimes difficult because they do have to be exact. The Q's have to be the same. So here's our first one. So our first statement is if a figure is a square, then the figure is a rectangle. So in my next conditional statement, to make this be use a law of syllogism, I have to use my conclusion. If the figure is a rectangle, then the figure has 4 sides. Law of syllogism says now, since these are the same, I can disregard them and say if a figure is a square, then the figure has 4 sides. Okay, so I'm going to kind of take out that middle piece. All right. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. Is the middle part the same? Is this the same here? No. So there, I cannot use the law of syllogism to make a third conditional that combines them. Okay? Notice that the parts that are the same are you are flexible. Okay? All right, now we're going to use the law of syllogism and detachment. So we're going to look at some examples and see if we can't use those laws. Okay, given. If you live in Accra, then you live in Ghana. Okay, so there's our first one. If you live in Ghana, then you live in Africa. Can we use the law of syllogism and the law of detachment? Well, okay, so now I have 2 if-then statements. Okay, so I'm going to look at the law of syllogism first. And is the middle pieces the same? You live in Ghana, you live in Ghana. Absolutely. So now I can combine that into one thing. Okay, so I could say, if you live in Accra, then you live in Africa. Isa lives in Accra, so then Isa lives in Africa. Okay, so we use both in that aspect. So the first part we have there. Okay, what did one math book say to the other math book? Don't bother me, I've got my own problems. Why isn't your nose 12 inches long? Well, then it would be a foot. All right, so that's the law of detachment and the law of syllogism.